Let's learn how to solve log equations linear. We're going to review condensing logs and then we'll get into solving. So let's get ready. You're going to need your notes and pencil, definitely a calculator. You should be trying and doing these problems along the way as well as getting them into your notes. So just to recap condensing, remember when we have the same log base and we're adding, addition condenses into multiplication. So this becomes log base 3 of 9x. When we're subtracting, it's going to become division. So this becomes log base 3 of 2x over 4. And when I have an exponent, it's actually a multiplication out in front. It becomes an exponent when I condense it. So this can become log base 3 of x squared. We're going to be condensing today as we try to solve. Also, we need to remember the change of base formula. So when we have log base b of a, remember the log of the base goes in the basement in the bottom of the fraction. So if I had log base 8 of 1/2, I would rewrite that as log of 1/2, close parentheses, divided by log of 8, and you can do that on your calculator. You're going to get an answer of negative 1/3. And if we think about that and rewrite this in exponent form, this becomes 8 to the negative 1/3 equals 1/2. We know that negative exponents move it to the denominator, and 1/3 would be the cube root. So this is the cube root of 8, which is 2, and then moved into the denominator, so it's 1/2. So this was the problem that we just did, exercise 1, and exercise 2, what's the difference here? Well, here's x, and I have all my numbers on the left side, so you can go right to the calculator on this one. I have x in the middle here. This is in log form. So for this one, I'm going to want to switch to exponent form. Here's my base, so I'm going to start there. So this becomes 7 squared equals x, and I can see the answer is going to be 49. So when you have everything on the left, all those numbers, log base something of some number, you can use your calculator along with the change of base formula. When you don't know what you're taking the log of, then you're going to switch to exponent form. So how can we do this one? Well, I don't know this x, it's kind of right in the middle, so I'm going to switch to exponent form, which is 81 to the 3/4 equals x. And now we can do that on the calculator, and we're going to get 27. Let's take a look at these log equations and tell me what you notice. Well, they have logs on both sides. All of the bases are equal, so I have 3s, 7s, and 4s. So far we've got log base 4, and then some parentheses. So because these are equations and these are all equal sign, that means the left have to equal the right. So if the log is the same and the base is the same, then the parentheses have to be the same. So here, we're not dropping log, we're not canceling log, we're just saying, oh, the parentheses have to be the same, so let's set them equal to each other. That's how we're going to solve it when you have the same log base on both sides, is you're going to set the parentheses equal to each other. And I think you're going to like these problems because they're really straightforward. They're back to algebra 1. I'm going to subtract x from both sides. I'm going to add the 1, and I get x to be 2. And then when I plug it back in, I can see I'm going to have log base 3 of 5 and log base 3 of 5, and now it's a true statement. Go ahead and try this one. We're going to set the parentheses equal because everything else is equal. We're going to subtract the x, add the 3, and we get 1. And you should be checking your work with these. So this is going to give me 3, and this is going to give me 3, and it's correct because we don't want to be taking logs of a negative, and so that may happen when you plug some number in. Well, let's try this one. I have log base 4, so I'm going to set my parentheses equal to each other. And let's see what happens with this one. We have 3x plus 8 equals x squared plus x. I notice this is an x squared, so we're back to quadratics. So when we have quadratics, we have to solve them. So I'm going to set them equal to 0. So I'm going to subtract all this stuff over. So I'm going to have x squared minus 2x minus 8. And now we're going to factor. So yes, some of these will end up being factorable. So I'm thinking of what multiplies to negative 8 and adds to negative 2. And that's going to be negative 6 and 4. Nope. Negative 4 and 2. So we're going to do x minus 4 and x plus 2. We set each of those equal to 0 and solve. Remember, that's the zero product property. So x could be 4, x could be negative 2. Your variables can be negative, but just be careful if you plug them in. If they make it the whole parentheses negative, then you have to exclude it. So when we do this one, they both do work. So we have two answers here, 4 and negative 2. What do you notice about this one? So this one has two log words. They're both on the same side. They're both the same base, which is good. And then on the right-hand side, I just have a number. So this is why we learned to condense. So when you have more than one log word, you're going to want to condense it. So now you have one log word, and then we'll be able to switch to exponential form. So remember, addition turns into multiplication. So this is going to become log base 6. I'm going to do parentheses, parentheses, because it's going to become a distributive inside. So it's x times x minus 9 equals 2. I'm going to distribute that. So I get log base 6 of x squared minus 9x equals 2. So now we've gotten it so it's one log word. I can go to exponential form. So start with your base, go to your answer. So this becomes 6 squared equals 9 squared minus 6x. I can see it's quadratic, so I'm going to set it equal to 0. And then we're going to factor, so it's minus 36. So I'm trying to think of two numbers that multiply to negative 36 and add to negative 9. And that's going to be negative 12 and positive 3. Because a is 1, I can go right to my parentheses. And we're going to set each to 0 and solve, so we get 12 and negative 3. With this first one, this is just log base 6 of x, so it cannot be negative. So we have to exclude negative 3, and our answer here is 12. This one, we have 3 logs and subtraction. So I'm going to condense to division on the left, and then we'll see what happens. So this becomes log base 3 of 56 over x equals log base 3 of 7. So now we're back to one of those statements where I had the same log on each side, so I can set the parentheses equal to each other. And it doesn't turn out to be as hard as we may have thought. So right now I have 56 divided by x, so I'm going to multiply everything by x, and I get 56 equals 7x. Still want to get to that x, so I'm going to divide everything by 7, and x equals 8. Here we have two log words. They are separated with a subtraction, so I'm going to condense them with division. This becomes log base 4 of 2x plus 2 over x minus 2 equals 1. Now I have one log word, so I'm going to go to exponent form. Remember, don't just set your parentheses equal to 1. You can't just get rid of that log 4. Start with the base, go to the answer. So this becomes 4 to the 1 equals my fraction. And I do have a denominator, so I'm going to multiply everything by the denominator. Distribute my 4, so I get 4x minus 8 equals 2x plus 2. Subtract the 2x from both sides. Add the 8. And we get 2x equals 10, therefore x equals 5. I did check it, and it works. Go ahead and try this one. Pause it. Try it, come on back and check your answer. This one does have some bigger numbers. I notice I have the same log base. I'm separated with addition, so I'm going to condense this with multiplication. This becomes, oh, and don't forget that 3. That becomes your exponent. So this becomes 5 to the 3, which is 125. Don't work through this with just the 5. That's what I was about to do. So this becomes log base 2 of 4 times 125, which is 500, and then we have an x in there, equals 5. I have one log word now, so I'm going to write it in exponent form, starting with my base. So this becomes 2 to the 5th equals 500x. This is 32 equals 500x. Make sure you divide the right way. The 500's with the x, so I need to divide by the 500, and it equals 32 over 500. That's a fine answer. And let's try this one. I've got two log words with subtraction. I'm going to condense it with division. So I get log base 7 of 9x over 6 equals 1. I'm going to write it in exponent form starting with my base of 7. So 7 to the 1 equals 9x over 6. Multiply both sides by 6. 42 equals 9x. Divide by 9, and x equals 42 ninths. No, did I do something wrong? Hold on one second. Nope, I think I'm good. 42 ninths. 9 divided by 6. Oh, I did. I forgot the square. Okay, let's try that. I felt like I did something wrong. So we have to bring the 2 up to the 6. So when I condense this, it's going to become log base 7 of 9x over 36. There we go. Equals 1. And I go to exponent form. So 7 equals 9x over 36. Multiply by 36. And we get 252 equals 9x. Divide by 9. And we get 28. Sorry about that. And just to kind of recap, if you have log base same number of a parenthesis equaling a parenthesis, you can just set those parentheses equal to each other and solve. If you have the same base and you're adding, you're going to condense with multiplication and then go to exponent form because it's going to equal a number. And if you have it with subtraction, you're going to condense with division and then go to exponent form. So once you're in log form, switch to exponent form. You may have to factor. Don't forget to check your answers. We don't want negatives. Nice job.